Hi guys, hi everyone. I believe we must be live and you should be able to hear and see me. You can just let me know if you can hear and see me. Okay, awesome, great. Uh, so this is a question that we have to solve today, and quite honestly, it's not a medium, rather it's an easy question as long as you are okay with some preliminary concepts of bit manipulation. So let's read the question once. But before that, anyone who was able to solve the question on his or her own, could you get an accepted on your solution? Okay, in the meantime, I'm reading the question. It says that we are given an integer array. This is the integer array. What we have to do is, okay, one more thing. The size of this array is n. Now we have to find and return array ARR of the same size n, whose prefix XOR array is this. So I'll try to explain it by some example. There is an operation which is called as XOR. It is a bitwise operation. I remember having taken some YouTube live session on some other questions of bit manipulation where we had XOR operator. So is anyone here who does not know about XOR operator? What is XOR operator? It's a bitwise operator, and it says that if you have two bits, let's say bit 1 and bit 2, and if you are taking their XOR, by the way, XOR has a symbol, hat symbol, then the result of this is something like this. The result will be 0 if both bits are same. So if both the bits are, let's say, 0 0 each or 1 1 each, the result will be 0. Otherwise, the result will be 1. As simple as that. So if, let's say, your bit 1 is 0 and bit 2 is 1, or the reverse, in that case the result will be 1. Okay, now going by this definition, there are some interesting outcomes, and if we first understand those outcomes, we can quickly solve this question. So let's say there is a number num, and if you take the XOR of the number with itself, can you tell me what will be your result? For instance, let's say your number is 6. So what will be the value of 6 XOR 6? For that to happen, what we can do is, we can first write 6 in its binary form. Yeah, Deepthi is saying 0, and 0 is the right answer. See, no matter what your number is, let's say your number is 6. What is the binary representation for 6? It's 110, right? So if you take 110 XOR 110, how will things happen? You have to do things bitwise because it's a bitwise operator. So first you will take XOR of this with that. Now both of them are same, both of them are 1 each, so the result will be 0 at that bit position. For the next bit position, again the values are same, like here also you have 1, there also you have 1, so it will be 0. At the next bit position also same, so again the result will be 0. So overall the result is 0. Now what it means is that if you are taking XOR of a number with itself, then no matter which bit position you are referring to, the values will be same, because it's the same number that you are having at both the sides. So at a particular bit position, same values will be there. So basically I can say numbers or number is always equals to 0. This is first understanding. Okay, what will be the XOR of a number when taken with 0? Can you think about that? Experiencing some echo. Is my sound clear to everyone? Can you guys hear me well? Apart from Deepthi, can others confirm it, please, whether I am audible or not? You can hear and it's clear. Okay, cool. Yeah, so let's go ahead. So let's say there is a number, and if you take XOR of that number with 0, what will happen? So think of it. No matter what your number is, let's say the binary representation of your number is something like this. Now if you're taking a XOR with 0, what will happen? At all the positions where you have 0, of course the results will be 0, because we all know that 0 XOR 0 is 0. Now at all the positions where you have 1, the result will be 1, because see, the other thing is 0 throughout. Now here, if you have a 1 here, it is guaranteed you will have a 0 here. So this 1 XOR 0 is going to give you 1. Similarly, this 1 XOR that 0 is also going to give you a 1. This 0 XORed with 0 is going to give you a 0. And then again for the next one you will have 1, and for the next 0 you will have 0. So it quite clearly means that if you take XOR of a number with 0, the result will be the number itself. Are these two things clear to everyone regarding XOR operator? Yes or no? Yeah. Okay. So now if I ask you a very basic question, the basic question is that let's say there is an array A, B, C, D, E. These are the integers in this array. Now in this array let's say you take the XOR of everything. If let's say you take the XOR of everything, what will be the result? The result will be A XOR B, XOR C, XOR D, XOR E. Okay, this will be the result. This is the overall XOR of your input. Now let's say there is another array. In that array you have same elements, but they are appearing in different order. Something like this, right? A, B, C, D, E, but they are appearing in different order. If you take their XOR, what will be the result? The result will be B XOR C, XOR E, XOR D, XOR A. Call this thing as your first result, result 1, and call this thing as your second result, result 2. Now if you happen to take the XOR of result 1 and result 2, can you tell me the answer? What will be the XOR of result 1 and result 2? It will be 0. Why it will be 0? Because it is guaranteed that if we have an A here, that there is one more A present over here, and we all have learned that XOR of a number with itself is going to be 0. So this A XOR that A will be 0. Similarly, this B XOR that B will be 0. This C XOR that C will be 0, 0 and 0. So everything is going to be 0, 0, 0, and overall result will be 0. This is an important thing to understand. Now if you understand this thing and if you revisit the question very clearly just says that you will be given an array as an input which represents the prefix XORs. So just like you have prefix sum, like what is prefix sum? You say that sum from here till here is just A, sum from here till here is A plus B, sum from here till here is A plus B plus C, this sum is A plus B plus C plus D, right? So this is your prefix sum array, right? Now in the question you have not been given prefix sum array, you have been given prefix XOR array. So I will just replace these additions by XORs. Okay, so this is what has been handed over to you. Okay, now keep it in your mind, this is not your input. Your input is this array is actually this. Now what you have to do is, given this, you have to derive that. So you have to derive the original array whose prefix XOR is given to you, and once you have derived that, you have got to return it. This is the question. So firstly, Everyone who is present here, are you guys clear with the question? Does it make absolute sense to each and everyone here? Yeah? Okay, great. So tell me, what comes to your brain? It's very simple. It just requires a very minimalistic logic building. Okay, so some of you seem to be suggesting few approaches, which looks good. Okay, okay, think of it in this manner. See guys, what would have been the prefix XOR till this part? It would be A XOR B XOR C XOR D, which is present over here. Okay, similarly, what would have been the XOR of this much part? A XOR B XOR C, which is present over here. If I call this thing as value 1 and if I call this thing as value 2, can you tell me the result of value 1 XOR value 2? What is this going to be equal to? If you take XOR of this with that, what will happen? A and A will vanish. A XOR A will become 0. B XOR B will become 0. C XOR C will become 0. Only D will remain, and 0 XOR D will be D, because we know that XOR of any number with 0 is equals to that number itself. So it means that in your given array, if you take the XOR of, let's say, ith element with I minus 1th element, then that will tell you what was the ith element in your input. Do you get the point? Why? Because let's say these elements these elements have been XORed up to create V1, and these elements have been XORed up to create V2. Now it is guaranteed that the first I minus 1 elements have been repeated in both the cases. So they will collide with themselves and become 0, and as a result of that only this will remain, and then it will represent the ith element. So I can technically say something like this, that the ith element of my array should be equal to prefix XOR till I XOR prefix XOR till I minus 1. You can think through it. Like if you want to know what is your element at third index in your actual array whose prefix XOR is given, then what you have to do is you simply have to take the XOR of your ith element with I minus 1th element, which is third element with second element. So that way the element which will be left out will actually represent the ith element of your array. Now this is the most important conclusion. This is the most important thing. Is it making sense? How many of you understand this idea? Yeah? Okay. One more thing. Can I say that, hey, the first element of my array should be same as the first element of prefix array? It's common sense, isn't it? Because when you talk about the prefix XOR of first element, it will be same as the first element. So you know what I can do is I can just go ahead and create an answer array of the same size. Okay, and then I can clearly say that answer of 0 is going to be prefix of 0, the first element itself. Now for all the remaining elements, which is from index 1 till index n minus 1, I am going to use the expression that I have written below. So we concluded this idea, right? So based on this idea, I can say that my answer of I is going to be the XOR of prefix I and prefix I minus 1. That's it. Now once this loop is over, my answer would have been populated with the deserving values, so I can finally just return it and expect the job to be done. But it looks like we are getting an error, compilation error, because we missed integer over here. So yeah, it works well. Can run it for multiple cases and see if it still works well. If it does, we can just submit. And it looks everything is okay. Great. The final thing is to talk about the time and space complexity. So what is the time complexity? Quite clearly I can see that the loop is running for n times, so the time is going to be order of n. Is there any extra space that we have used? So there are two things here. See, some people will say that we have used an extra space of order n because we have created this answer array. I would say this was unavoidable, because the question wants you to return an array, an extra array. It wants you to create it and return it, so probably this was unavoidable. Apart from that, we have not used any modifications, right? So you can say that, yeah, my total space complexity happens to be order of n, but apart from the output, I have not created anything else. You know, some people, what they do is they perform manipulation inside this array only. I mean, instead of declaring an extra array, they try to perform manipulation inside this. You should also try doing that and see whether that's possible also or not. But yeah, overall, this was the concept. The underlying, the foundation idea of all of this was these two things. You can solve so many questions on bit manipulations if you are clear with these two properties of XOR operator. Okay, so was it clear? Like, especially to those of you who are not very confident with bit manipulation, could you understand how this question has been solved? You can write a yes or no to let me know. It was quite an easy question today, right? The discussion was just a breezer. We did not have to use a lot of head to get it done, right? Okay, great. So let's hope for a slightly harder question tomorrow. Yeah, and then let's meet again tomorrow. I think we have concluded pretty quickly here. You can go back and you can solve this question, and you can also do one thing. You can probably look at the similar questions. All of these are good questions based on the similar concepts, and you must try them out. So that will give you a clue whether you can apply whatever you have learned from today's class or not. Okay, great then. So that will be it. Bye everyone, and good night for today.